Welcome to the AnandTech podcast. For a rare podcast treat, this is episode 42. I am your host, Ian Cutress, senior editor, and joining me today we have Ryan Smith, our editor-in-chief.
Hey, everybody.
Now, the reason why we've come out of the cave to record a podcast is because we have had what I'm describing as a week of madness. There are a few times in this industry where news kind of comes out of left field and it requires a much deeper analysis. So it's rare for that to happen, but it does happen. And then it's rare for it to happen 3 times in the same week. I'm not sure how you feel about this, Ryan, but the announcements of Intel and the 2 announcements relating to Raja Koduri this week have, I think I woke you up for one of them, didn't I? So you could write it up.
Yes, you did. That would have been Raja Koduri leaving AMD. I've been calling this the Raja Koduri saga just because it has certainly been an incredible week. You know, we start off with Intel and AMD working together, then AMD's graphics chief leaving the next day, then the day after that, he joins Intel, where that's actually not the biggest news of the day, but instead the biggest news of the day is that Intel's getting into discrete GPUs. I mean, this is one of those weeks that's essentially going to turn a whole industry on its head. It's the kind of thing that happens once a decade.
We were planning for this to be a slow entry week into Supercomputing 2017, the trade show that starts next week. But no, it's just go straight from here on out. So I'm going to start this podcast off with our first topic, and that's talking about new products coming from Intel featuring AMD Radeon Graphics. Now, I suppose we have to give props to Kyle Bennett from Hard OCP here for he mentioned it on a forum post, and then he's been tracking the story, and nobody really believed him for several months until Monday.
No, I didn't believe him either. I mean, much respect to Kyle. He's a good fellow, but it was such an audacious story that I wasn't expecting it to be true. I figured he's being fed bad information, possibly somebody throwing out bad leaks in order to see who's leaking it.
Well, so Intel and AMD, as I'm sure most of our listeners know, have been fighting the x86 CPU battle for, 30, almost 40 years now. So AMD used to be a second source for Intel, but it's now just turned into, with all the cross-licensing agreements going on, Intel versus AMD when it comes to x86. AMD bought ATI, got into graphics in a serious way. Intel stuck with integrated graphics, and now we have a situation where Intel is going to start buying chips from AMD to use inside their single package solution. Any thoughts on just that being as the headline? Intel with Radeon Graphics?
That alone would be plenty of fodder for a wild week right there. Intel and AMD, of course, are classic competitors. Not so much in the GPU space as the CPU space, admittedly, but still big competitors. So the fact that Intel is essentially contracting out GPUs to AMD for this one specific product, it's just so weird. I'm not necessarily going to say groundbreaking because I expect that we're only ever going to see a couple of products like this. Clearly, Intel has their own plans going on, but the fact that somebody got Intel on board to develop a chip that includes a Radeon, it separates Radeon GPU die on the chip itself is quite an achievement, to say the least.
I mean, Intel plays primarily in the CPU space and the server space for PCI accelerator cards. They're its main 2 markets. You've got AMD who focus on the CPU and the discrete GPU markets, and then you've got NVIDIA who play in the GPU and the PCI accelerator enterprise space. So if you just take each of those 3 companies as covering 2 of those 3 markets each, you've now got a case where Intel is encroaching into a third, almost.
It is, but I suppose we're getting ahead of ourselves in terms of the Intel Discrete GPU announcement. As far as the specific Core H CPU announced on Monday, which officially has no name, but I've been seeing everyone call it Kaby Lake G, and well, for lack of a better name, I probably will as well. Kaby Lake G is just an interesting development. As I mentioned before, I don't think this is a long-term thing for Intel, contracting out to AMD like this. Rather, I interpret this as being something that one of their customers requested, more likely multiple customers. The obvious candidate here being Apple. Apple has seemingly solidified their x86 Macs based around using Intel CPUs and AMD GPUs. This is what they've done for about the last 5 years now. So a chip that includes an AMD GPU on it sounds very much like the kind of thing Apple would want to throw in, say, an iMac or possibly even a MacBook Pro.
I mean, the major benefit, which Intel is right in their announcement of a design like this, is that you can reduce the board area, the motherboard area that contains all the ICs, which by virtue leads to more space for battery.
Correct. So a normal design right now, like their current 15-inch MacBook Pro, you have a separate Polaris 11 GPU and its memory. And if you've ever seen it teared out, it's actually not all that huge amount of space, but still, this is Apple. Every square millimeter counts. If they can save space, they'll put a battery in there, they'll put some other feature in there, and they'll generally make good use of it. So being able to compress space down helps. But also part of the Intel announcement that caught my eye was the discussion of power management. Unfortunately, Intel's announcement was very high level here, so it didn't go into any great detail. But the way they discussed it, it sounds like they have a greater power management capability in terms of balancing power loads between the CPU and the GPU than what you can do right now with a off-chip GPU a la the Apple solution. So it sounds like this not only gets Apple, a more compact solution, but it sounds like they can also squeeze better power efficiency out of it in the process.
Well, so just to recap what this Intel with Radeon Graphics, Kaby Lake G, whatever you want to call it is a single CPU package containing multiple bits of silicon. Now, that's not new. We've seen Intel CPUs paired with Intel chipsets before. That's not new. What is new is it's containing a Core H series Intel CPU. Now, Core H is typically their 35-watt, 45-watt high-end notebook part, containing usually 4 cores with what they call GT2 graphics. Then, alongside that, we have the AMD Radeon Graphics chip, the one that's being sold to Intel for this package. And then connected to the AMD graphics is a stack of HBM2, High Bandwidth Memory 2, using Intel's EMIB, that's Embedded Multi-Die Interconnect Bridge Controller. Now, altogether, that's a mouthful if some terms are unfamiliar. But what we essentially have is one of Intel's highest performing mobile CPUs connected to a form of AMD GPU via what looks like to be a standard PCIe link, just it's on the same package. And then the AMD GPU is connected to the high bandwidth memory via what is essentially Intel intellectual property, this embedded multi-die interconnect bridge, or EMIB, which allows for a higher bandwidth transaction between the GPU and the high bandwidth memory. Now, we've seen HBM2 in discrete GPUs. Fiji was the first, and then we have NVIDIA's P100 and V100, and then Vega. Vega uses HBM2, right?
Correct, yes. Fiji was originally HBM1. All those other products you mentioned use HBM2, and all of those products use a full-on silicon interposer to connect their memory to the GPU. The silicon interposer is sort of the more straightforward solution. The problem is that silicon interposers are large, generally larger than the chip plus the memory itself, and that incurs costs just due to size, but also technical difficulties because you can only make them so big.
So the point about Intel using EMIB between the Radeon Graphics and the HBM2 is all a question of bandwidth and power. Now, there are typically, I guess there are three standard ways of connecting bits of silicon together. Either you have them both in the same bit of silicon anyway, so you make a silicon connection. The second is that you connect them on a package, so that's just standard through a standard PCB substrate. And the third is, as you mentioned, using this sort of underlying silicon interposer that you put all the different chips on and they connect through. What Intel has done with EMIB is essentially made a fourth way. it's designed to have the high bandwidth of an interposer, but none of the cost, or at least a low amount of cost, by essentially trying to put an interposer into the PCB.
Yeah, I'd essentially call it silicon interposer light. Build just a big enough chunk of silicon to do the interposing, place it into the PCB so that it's essentially out of the way, and that'll handle all your routing needs. It's really a neat technology, and correct me if I'm wrong here, this is the first Intel product we've seen announced that's going to use it.
They have technically announced FPGAs under the Intel Altera Stratix brand that are
Right.
obviously the FPGA market is and that's an enterprise market, and that is their high-end product in that market. So of course the consumer visibility of such a product is next to zero anyway. But what this sort of EMIB technology allows them to do within a single processor package, so that's a package with multiple silicon dies, is you suddenly now have up to 256 gigabytes per second bandwidth to the GPU, depending on frequencies and so forth. But previously, when you had a combined CPU and GPU in the same package, you had to go out to main memory, where your memory bandwidth was limited to maybe 15 or 20 gigabytes per second. Now we have 10 times that in a singular package for the graphics. Now, I've played around with integrated graphics a lot. I know you have a bit as well, Ryan. Memory bandwidth is a serious bottleneck.
It is. My memory bandwidth it is what GPUs consume. They live and die by memory bandwidth. Memory bandwidth development is part of the general computing landscape. I don't want to say only GPUs need memory bandwidth, but they always need the most as far as products that get in consumers' hands. So there have always been various solutions over the years to try to do something about that, either increasing the memory bandwidth via technologies like EMIB to get HBM2 on there, or even something like local caches a la Intel's Crystalwell technology, which is their EDRAM that they would put on chip with certain high-end configurations in order to give their integrated GPU a boost in performance.
So the integrated DRAM, which we saw in Apple's iMacs, that changed the memory bandwidth from the DRAM of 15 to 20 to 50, and now we're going from EDRAM of 50 to 250. It's paired with what configuration we think AMD might be putting into this Radeon Graphics chip that they're selling to Intel. It has the potential to be a nice graphics design. I mean, Intel has stated it's going to be capable of premium VR. Now, how many AMD Radeon compute units do you need for VR?
Right now, really for VR, you want to have a GTX 570 or better. So you're looking at, let's see, off the top of my head, 28 or better compute units.
So so an RX 570.
Correct. And so, actually, funny enough, you bring that up because you've actually done the math on this. Based off the size of the HBM2 package, what we calculate out the die size of the GPU at, based on the photos we've seen, very close to the size of Polaris 10.
That just brings up more questions. I mean, this is AMD selling its GPU technology to Intel. Now, one would assume that Intel has buckets of money, so they'd pay for the latest technology. Why would they buy Vega or would they buy Polaris? What even would AMD sell? Would AMD sell only Polaris and keep themselves one generation ahead, or would they want to take the money and offer Vega?
So those are very good questions. It's one of those matters where there is no simple answer. Obviously, if you're AMD, you're working with Intel, it's sort of a dangerous game. You may not necessarily want to throw Vega at them. At the same time, you have to look at the timeline of when this product is going to come out. We're probably 9 months to a year away from actually seeing this chip.
Really?
At least that was my impression, that this is something that's still in the farther future. But Intel could surprise us. I don't believe there was a date attached to their announcement.
I was under the impression that we would see products using this technology by the end of Q1 next year.
That would be very interesting if that's the case. Either way, it's a 2018 product. Polaris was AMD's top-line architecture for 2016, and not to knock against AMD, even then, Polaris is really just a souped-up version of GCN3, which fundamentally goes back to GPUs released in 2014. So it's a fairly old architecture, all things considered. So you definitely would want to start with something like Vega if you want to just maximize your potential. And AMD has already put together Vega-like products for other companies. The PlayStation 4 Pro's APU, for example, integrates pieces of Vega technology, and that was released a year ago. So AMD is in a position to push Intel towards Vega. Whether that's what happened or not, we're going to have to see. Like I said earlier, there's certainly an argument to be made for not giving Intel the best. The flip side of that is that Intel's integrated GPUs are actually, I would say, more feature advanced than Polaris. They actually support higher tiers of the Direct 3D feature tier list than Polaris does. We're talking feature level 12.1 with all the bells and whistles on the latest Gen 9, Gen 9.5 GPUs from Intel, whereas Polaris is more of a basic feature level 12.0 GPU.
There's also the additional that Vega was built with HBM2 in mind. Polaris wasn't built with any high bandwidth memory in mind. So, I mean, the GPUs are built for the memory technology they're going to go with. So,
exactly. I will throw in two other things here. While yes, Vega was built for HBM2, bear in mind that AMD has a mix and match strategy for GPUs is the best way to put it. They're essentially built from, or at least designed from various functional blocks. So use this version of a memory controller, this version of the core ALUs, this version of the display controller, so that they can put together semi-custom products, be it for Microsoft, Sony, or now Intel. So it's very possible that they could take a Polaris core design and swap in a newer memory controller essentially derived from Vega. So HBM2 is by no means a guarantee that it's Vega-based.
I just want to come back to what you were saying about Intel's graphics capabilities. Now, it has been confirmed that the CPU within this, Intel with Radeon Graphics products will have Intel's own integrated graphics alongside the Radeon graphics. That makes sense from our perspective because if you're going to watch video, you don't necessarily want to fire up power-hungry discrete graphics and HBM2. So we suspect that it will be using decoder to watch video. That means that at some level there will be a switchable graphics topology involved.
Sure, that makes a lot of sense. A switchable topology does have its drawbacks, but again, assuming that this is first and foremost for Apple, Apple has a good lid on their graphic switching capabilities for their existing products. So switching between the two was not an issue for them. On the PC side, it's a little more complex, but not massively so. This is going to be a specialized product that's only going to go into certain kinds of devices. It certainly is not going to be a mass market product on the scale of any regular Intel CPU.
It also means they can support quick sync.
Yes.
So, I mean, I've had an opportunity to speak with AMD on this. Now, understandably, because they're literally just selling the chips to Intel, they're not saying much because it's Intel's product, it's not AMD's. But, they were able to confirm it's not a cross-licensing deal. This is literally just a chip sale based on, their GPUs with semi-custom features. So one of the questions when it came out was, well, if the AMD GPU is using this, Intel EMIB technology, does that mean AMD can use EMIB for their other products? The answer is no. Intel has literally just given AMD, sort of the EMIB connector block to put into their floor plan and connect it to HBM. So literally just selling chips. That means that any information that's going to come out regarding the product, regarding the configuration, regarding power consumption, is all going to come from Intel. I mean, CES is, 2 months away? That's typically where we see a lot of laptop announcements and where we'll see things like Ryzen Mobile be presented in all its glory. But this product we won't hear anything from AMD. It'll only be from Intel.
Yeah, and as has always been the case for the semi-custom works, they might say a word or two, but when you do a semi-custom buy from AMD, they are your supplier. Suppliers do not talk to the press. It is the owner's job to do that.
I mean, we see that with Sony and Microsoft on the consoles.
Exactly. And interesting, and on a slight tangent here, both had been very open with their consoles this year. That with the PlayStation 4 Pro and the Xbox One X, so that was a neat change. But again, all of that was instituted by them. That wasn't AMD's doing.
Well, one thing I did ask with AMD, which I told you a little bit earlier, Ryan, I think surprised you. So we're seeing this as what is essentially a win for AMD's semi-custom division. So I asked, will we see the profits from this agreement be reported on the semi-custom financial sheets? And they turned around and said, no, it will come under the computing and graphics division, not the semi-custom. And the reason behind this is because it is essentially a GPU chip with semi-custom features as opposed to a fully semi-custom design like console.
Yeah, from the sounds of it, it's going to be a scaled-down version of some AMD GPU. They'll need to put in display controllers. They may or may not put in video encode blocks, but you still need the PCIe controller. You still need all the core architecture. You still need a memory controller, etc. So it is very close to a GPU. I mean, what Intel has done here is essentially place an AMD GPU and its necessary features near a CPU. They have not done anything to integrate the two.
We assume it's a PCIe link, and that's everybody knows how to put a GPU over PCIe. So
yep.
I did ask whether the GPU would be branded AMD, whether it be Intel with AMD graphics or Intel with Radeon Graphics. Apparently that decision has been made, but nobody will tell me. We're going to have to wait until it actually gets launched.
We'll find out in due time. Intel's not going to be able to hide the nature of these graphics if it goes to anybody except Apple, because those users are going to need drivers. And unless they want to put together a completely separate drivers stack that removes all mention of AMD, the name's going to sneak in there.
Actually, speaking about drivers, so I did ask regarding the driver situation, because Intel did kind of half mention it in their announcement, and AMD said they'll be providing the driver stacks to Intel, and it's up to Intel to distribute them how they seem fit. So what is likely to happen here is if you want the drivers, you have to download them from Intel, which I think is going to be a little bit confusing, because if your chip has Radeon Graphics, if you search Radeon Graphics driver download, you're going to hit the AMD webpage, not the Intel webpage. That I was told that is something that Intel is just going to have to work out.
Yeah, let me throw out this counterpoint, though. This is very similar to how graphics drivers download worked for Apple's laptops when you're doing boot camp. Even though there's an AMD Polaris 11 GPU or previous generations other AMD GPUs on there, you still have to get your drivers from Apple. Regular Radeon drivers will not install.
Well, I mean, we keep saying Apple, and we assume that this is going to be an Apple product, given how strong Apple has pushed integrated graphics from Intel recently. There is possibility that we're going to see it from other OEMs in the Windows space. Though I hear that much like the EDRAM parts, this is going to be high cost, and I'm not sure which OEMs are going to take advantage of that high cost. I guess we'll find out at CES maybe.
Yeah, the thing about EMIB is it's cheaper than doing a silicon interposer. It is not cheap. You figure AMD is going to sell this GPU, they need to make a margin, and then Intel wants to achieve their historically high margins on top of all this, so yeah, it adds up. Of course, when you're somebody like Apple, where you can sell a MacBook for $1,500, $2,000 more, maybe you can afford that. If you're somebody like Dell, you can maybe fit into something like an XPS series laptop, but in general, the PC OEMs have been very skittish about paying extra for graphics. And that's always been a struggle with getting the EDRAM SKUs from Intel adopted in past generations.
It's really going to be interesting to see how many different power envelopes that Intel makes these parts. I mean, we've discussed a 45-watt Core H series CPU. We've described something that probably has around 25 compute units, though we don't know yet. And for that to be VR capable, that's going to need to be drawing upwards of 45 watts by itself. Then you have HBM2 and then the interconnect. This could potentially be an SoC that has a TDP of say 55 watts, and depending on the how the power management works, it either fires up all the CPU or all the GPU, or a mixture of both, depending on what's needed. But we could be breaking ground in TDP numbers. If it's going to end up in laptops, I mean, it could just end up in an iMac, and your power budget there is a lot more.
It is. The thing about the iMac is, and we'll try to go too far down the Apple hole here, is that the iMac has plenty of space. Apple is still builds it like a laptop, but they don't need the space savings on an iMac as bad as they do a MacBook. Now, you're absolutely right. There's potential here for a lot of TDP, a lot of power consumption and heat. Just the die size of the GPU component alone, like I said earlier, is Polaris 10 size versus Polaris 11 in your current MacBooks. So if you try to bring those up to proportional power levels, you already have a much more powerful chip right off the bat. Now, second bit here while we're on the subject, and this goes back to your die size measurements, you also computed the die size of the Intel chip based on the HBM2 memory stack. Now, how big did the Intel CPU end up being?
If I remember correctly, it was about 149.
Yeah, so roughly what we estimate the 6-core Coffee Lake core to be.
Well, yeah, I think the 6-core Coffee Lake is about 142, or it's the other way around. I measured 142 and the Coffee Lake is 149. Either way, it's within sort of I'm measuring pixel counting pictures here, so there is a margin for error.
There is,
but a 6+2 Coffee Lake design was within sort of 10 square millimeters, whereas the alternative would be a Kaby Lake 4+2 design, but that's down at 125.
Exactly. So we could very well be looking at a Coffee Lake plus Polaris 10-ish GPU configuration all on a single chip. In which case, yeah, you could potentially draw a lot of power. The flip side, however, is that if you go for power savings, you keep the clock slow, you have two very wide chips that, when not put to insane clocks, actually don't draw all that much power.
Sort of goes down to how Intel's doing its power management. I mean, they could do what AMD's doing with Ryzen Mobile and have a single power rail and internally it's determined how that power is split based on what they can turn off and what they can turn on. Or they have dual power rails, but then that increases the board area. So previous Intel CPUs that would have been used in these devices would have just had a single power rail for the CPU, and then obviously all the GPU features. So these are questions that I have that I wish Intel would answer. I guess we'll find out soon. You could just bin to 15 watts, maybe.
Yeah, I do. 15 watts would be interesting, to say the least. I'm not going to scratch it off. Definitely would be a surprise given the sheer amount of silicon that they're throwing at this. But again, it's all about how much money you want to spend. Silicon is simply money, and if you're making it hand over fist, you can afford to spend it on these kind of luxuries.
There was a comment towards whether this product is going to compete with Ryzen Mobile, and I believe the comment was officially kind of not really, for now. That for now is me adding for now. I mean, Ryzen Mobile is currently targeting the 15 watt power envelope, and this is targeting something a lot more, but at some point there's going to be some overlap, I think.
Yes, quite possibly. Again, depends on how they want to configure it. You can always turn down the TDP if you want to get it in smaller devices. Now there is a limit because this looks like it's going to be a big chip, especially compared to designs where you previously didn't have a discrete GPU. Now you have one on there that takes up space. There's also some question about just how thick this chip is. It's certainly not going to be a petite chip like Polaris 11 or Intel's U&Y series parts, so it may not be well suited to go into 15 watt style devices to begin with.
Well, the advantage over Polaris would be that you don't have memory chips dotted around, I guess. So regardless of the size of the silicon, you're not spending board area on memory.
True, very true.
On the image, there is a package, what looks like a package stiffener. So the package is big enough that it needs reinforcement, which is going to be interesting. I don't have much else to say on this chip, except that we weren't expecting it. It's going to be an interesting play, and I think the key metric on how successful it is will be determined on what OEMs it will end up in.
Very much so, yes. I would say for enthusiasts listening to this, enjoy this moment while it lasts. I don't expect Intel plus AMD chips like this are going to be something we're going to be seeing for more than a couple of years at the most. So maybe get one to throw in your CPU collection here while you can. But for now, it's a very interesting development and one that I'm sure is going to make a couple of OEMs very happy.
Yeah, I'd love it if they put it into a discrete processor. Then I'll stick it in my collection. I doubt that will happen though.
Yes, you'd have to either get one from Intel or rip it out of a laptop, unfortunately.
Yeah. Okay, so second topic for the podcast. Now it's the Raja Koduri saga. But I'm going to split it up into two segments because they happen across 2 different days and it's easy to talk about. So the first segment I want to tackle is Raja Koduri announcing that he's going to leave AMD. Now, he was technically on leave for...
Yes, he was on a sabbatical through December.
So this was from August, I think.
Yeah, start of September. Yeah, September through December.
Yeah. And so, there were questions postulated at the time that, normally when people take sabbaticals, then that's just a precursor to them quitting or leaving. Now, that's true in certain industries. However, in tech industry, it's not uncommon for people to take 6 month sabbaticals. Like, for example, I know Intel, and I think they still do, if you're at a certain level or above, if you've worked there for 10 years, then you're given a 6 month sabbatical for you to go rest, recuperate, pursue what you want, and then come back to your job and continue. So, but Raja's sabbatical was kind of out of the blue. He basically turned around and said the launch of Polaris and Vega had taken a lot out of him, and he wanted to recuperate.
Yes, so, and we found out a little bit more about this yesterday. Apparently he's been auditing college classes with his daughter, which is an interesting way to spend your sabbatical, but yeah, it definitely gives him some time to learn, some time to spend with family, etc. I mean, I don't know if there's really too much to say about the sabbatical itself. AMD is not a company that's at least not publicly known for employees taking long sabbaticals. So the fact that Raja went on a sabbatical like that was always questionable in terms of, is it really sabbatical or is it a prelude to Raja resigning? And well, now we have our answer.
So he leaves. He says that he's taken stock of his position, of what he wants to do, and he wants to go on a different path. So that's Raja leaving. Now, Raja was head of the Radeon Technology Group at AMD, the dedicated GPU division specifically for doing GPUs when it was spun back out of the combined CPU-GPU team. That was what, 3 years ago?
2 years ago. So the Radeon Technology Group was formed in 2015. It essentially puts everything involving GPUs back under one division. Previously, the hardware was essentially one division, and the software would be another part of the division. And you just had this sort of not always fully functional layout where everybody had a stake in GPUs, but because they weren't completely controlled under one person, no one person was essentially empowered to do things about it, to get certain things fixed. For example, improve vendor relations, make stronger decisions about driver development, etc. So by putting things in the Radeon Technologies group, the idea was to consolidate all of this, give Raja total power, and allow him to improve things by treating it as its own sub-business.
It basically confirms that the whole original idea of bringing CPU and GPU together to create what was a unified APU division, that idea kind of failed. It wasn't having the desired effect internally and on revenue.
Yeah, and I could really go into easily an hours-long spiel on the subject, which I'll avoid for this podcast. But yeah, the fusion concept isn't dead at AMD, even if the name is. But yeah, the tightly integrated CPU plus GPU, giving them performance that couldn't be done on a CPU alone, has not panned out the way AMD has wanted to. And while they're continuing to build products along those lines, and we may yet still see such a day come, it clearly wasn't the best way to design a GPU, as discrete GPUs are not going anywhere.
No, the way I understand it, correct me, is that RTG was essentially created for, again, Raja to be the boss, Raja to be not only the spokesperson, but the front-facing media guy. He would have complete control over the design. There wasn't really a public-facing number two. I mean, you said RTG and Raja in the same breath as if they were the same thing.
Correct. He was functionally the CEO, at least from a public relations perspective.
So he leaves. So he announced that he leaves, or at least from the beginning of his sabbatical. The CEO, Lisa Su, took over RTG, was managing the day-to-day running of RTG, and now that Raja has left, she's still running the day-to-day for RTG. Now, the question is, what's going to happen there? Obviously, Lisa Su as CEO, I'm sure she can do both jobs perfectly well, but they will want a dedicated head of that team at some point. Now, will that come from internal, or will they look externally for that? And who's capable for the role?
All right. Well, that's an excellent question. Yes, they're absolutely looking for somebody. In comments to me, AMD has confirmed that they're already searching for a new individual to lead the RTG. The way they phrased the comment makes me suspect that whoever leads it is going to be an outsider as opposed to an insider. Just the way you do a search. Generally, you don't search from within. At least you don't publicly announce that. Instead, you already have your line of succession figured out. So the fact that AMD wants to do a search means that they either don't intend to promote from within, or their choice from within they're not fully confident in, so they want to look at their outside options. Either way, I think the nature of what's going on means that they're more likely to pull in somebody from the outside.
Are there not any legal issues that you have to advertise the job or anything? Is that a thing over
there? You do sometimes have to advertise a job, and this probably gets into California law, which I'm not especially well versed in.
True. So, it's. I mean, RTG, they've released Vega now. The next product on the roadmap is Navi, and that's likely what I know. They're probably so far enough along in the development of Navi that it's just cleanup work, and then tape out on production whenever that's coming to market.
Yeah.
So a good deal of R&D will probably be on post Navi already. Now would Raja have made his input into post Navi? Yes.
Yeah, absolutely.
Would the person coming in have input into Navi? Probably.
Well, person coming in input into Navi? No, probably not. Not if Navi is to come out in 2018.
Oh, true.
Which at this point is questionable. AMD's original roadmaps pointed to a 2018 release, but Vega essentially missed its proper launch window the first half of 2018. Instead, it came out a couple months later, towards the end of August, for the consumer parts. So I would be surprised at this point if we do see Navi in 2018. But again, we don't have any sort of well-defined window for that. It could very well be, a fall launch for AMD. But either way, tape out will be soon. So any chance to make big input has already passed.
Fair enough. Okay, so that's AMD RTG. Now, immediately after Raja announcing that he was leaving AMD, obviously the questions came along, well, what is he going to do? What's going to happen? Now, normally when somebody that senior leaves a company, they either the same day announce that they're going somewhere, or they disappear off the face of the earth for a few months and then pop up somewhere. We only had to wait less than 24 hours to learn that he was becoming one of the senior management at Intel. And given the fact that it was 24 hours from leaving to joining, clearly this has been in the works for a while. Wouldn't you agree?
Oh, yes, absolutely. Even discounting rumors for a second, to organize something like this would take months on end.
So you can imagine Raja being up, explaining the great Vega chip while in his mind thinking, well, actually I'm going to go to Intel in a few weeks.
Unfortunately, yeah, pretty much.
But, I mean, hey, he joins Intel. They've created a new core and visual computing group to which he will lead as senior vice president. He joined AMD and got a RTG for himself, and now he's joined Intel, and now he's got his CVC to himself.
Yes, I mean, while Vega may not have been the product that AMD would have liked to have, I don't doubt to any degree that Raja isn't a very capable leader in the graphics space. What AMD has been able to do with their limited resources on Raja's 2 times at the company, and while Raja's working at Apple, all points to him internally being a very capable leader, and externally, of course, Raja was the capsicum of RTG. So, as a now visible Intel executive, he is going to sort of continue that same trend that he started at RTG, and I'm sure he's going to be able to give Intel's employees and engineers sort of the guidance and enthusiasm and architectural insight that they need to produce good products.
Okay, so this begs the question. I mean, Intel has its finger in so many pies already. We've got PCIe accelerators in the data center. We've got FPGAs. We've got AI with Nirvana and Vidius and Crest Lake. But Raja's expertise is in discrete GPUs. Does this mean Intel's going to start creating discrete GPUs?
You're damn right it is. And that's what's so amazing about this announcement. I mean, the GPU space has functionally been a two-party system here for 15 years now. Ever since Matrox, S3, and Imagination got run out of the discrete GPU space, it's been AMD and NVIDIA. Now, Intel's made a couple of efforts to get in here, most recently with the failed Larrabee project, but as far as actual shipping silicon, this has been AMD and NVIDIA's game for most of the life of discrete GPUs. So yes, this is a very interesting development. Intel is going wholeheartedly into producing a discrete GPU, and they've managed to line up a person who has significant expertise in GPU architecture and specifically discrete GPUs to help them accomplish it. Just going from Intel's announcement here, they very specifically announced high-end discrete graphics. Now those two terms are very notable because one indicates we're not just talking about upscaling Intel's integrated GPUs to do something like replace the previously mentioned Kaby Lake G part. Produce an Intel chip where it has an integrated GPU powerful enough where you don't need an AMD GPU. No, they're aiming for the high end here. We're talking about NVIDIA GTX 1080, 1080 Ti class, things that would be actual high end in the discrete GPU space.
Right. Okay.
And as for graphics, I think that's a notable way to phrase it because it indicates that this isn't just going to be a compute only chip. Because if it was compute only, you wouldn't use graphics. When you say graphics, it means you actually want to do a proper GPU.
Oh, okay. So when I initially heard this, and high-end graphics, great. Well, I mean, Intel's cash cow is the data center, so it stands to reason that whatever they produce, it's going to be data center focused. Now, you are right. If you're doing compute, if you want compute, then you build a compute chip. You don't build a graphics chip. But do you remember the Visual Compute Accelerator that Intel launched a couple of years ago, where they strapped 3 Crystal Well-based CPUs onto a PCIe card and sold tons of them to TV Stream, TV Inc. That's technically graphics conversion. I mean, it's compute task. Are they not just muddying the waters by saying graphics?
They could be, but then why hire somebody like Raja?
I guess I know. From my mind, I think the enterprise graphics space is perhaps more lucrative than the consumer graphics space.
Yeah, consumer graphics is a nice side business. Let's take NVIDIA, for example, because they are ruling the roost, and their earnings just came out today. So the bulk of NVIDIA's business is still consumer graphics. However, it's not the most profitable part of their business, and more importantly, while the business is growing as a percentage of NVIDIA's business, it is actually shrinking. It's at 59%, and data centers willing here, NVIDIA would be perfectly happy if it flip-flopped and data centers were their leading business. But one thing it's proven with NVIDIA's efforts is that GPUs do very well in the data center, and I'm sure that's Intel's primary concern here. I mean, yes, any GPU that they make will primarily, at least on the high end, where they need to compete with NVIDIA, will primarily be for compute purposes, but it will still be a GPU as opposed to another kind of compute processor.
It's I mean Nvidia's like the P100 and the V100. I mean they sell individually for what 10k a piece, but you can buy 8 of them in a system for 150k. So that is a super high margin product. And what does Intel love more than anything? High margin.
60% or bust.
Yep. You've got AMD trying to get 35. So Intel going 60 plus, going into a high-end graphics and by extension compute. Now a project of this magnitude, I mean, if they're bringing on Raja, you might think, well, we might have some design ideas already inside. Well, they may not. So we're 2-3 years away from Intel producing a product. Raja could go into hiding for 2 years, and then we finally come out 2019, 2020 with a GTX, I don't know, I guess it'd be 3080 competitor or something.
Yeah, so there are a number of different ways this could go. In the short term, Intel could leverage their existing Gen graphics architecture, essentially scale that up to something discrete GPU size, just to get something in the market. For all we know, Intel could have started a new discrete GPU project a couple of years back, although admittedly I would expect that we would have heard about that by now, just because that kind of product seems difficult to keep silent. And then the third option being that they're going to start a new project under Raja, which is the longest term outlook. Anything that Raja starts on now wouldn't be out until 2022, which is still a long ways away.
Well, one of the benefits Intel has in the IP, I mean, IP is a dangerous business when you're changing companies like AMD to Intel. Now Raja's done it several times, so he kind of knows where the lines are and where he's treading or not treading on other people's IP. I have full confidence in him to be able to do that. But integrating Intel's key IP, which could give them advantages here. I mean, we've already seen it in what we've discussed today. Using EMIB to enable HBM2, or we could use EMIB to enable, one of the problems with using such process nodes like Intel does at 40 nanometer initially came out and then 10 nanometer is you have problems with yields. So if you can string 5-6 chips together via EMIB and still keep the bandwidth pretty happy, you could suddenly be looking at GPUs that have much higher total die areas than what are currently available today. So if you wanted the equivalent of 3 high-end graphics cards into a single package on a single PCB, Intel has the technology to do that. NVIDIA doesn't currently.
Yeah, the keyword there is currently, if Intel is tending to go after NVIDIA and by all signs they are, NVIDIA is by no means a small player anymore. They're booking almost $1 billion in profit in a single quarter, so they're still far from Intel size, but they are no longer small potatoes. They are an active and real threat to Intel. And all this growth that NVIDIA is experiencing, much of it has come at the cost of growth that Intel could have picked up instead, and in past years would have been Intel's growth.
I think, I mean, I keep banging on about EMIB because I think it's perhaps such an enabling technology. But, we're currently dealing with GPUs that are stretching the limit of manufacturing capabilities. We're at the reticle limit for things like V100. The only way to get more parallelizable compute is through EMIB. So,
correct. Yeah, no, it is a very interesting technology. I would not be the least bit surprised if not NVIDIA, then in a partnership with a foundry, that somebody wasn't developing a similar technology for external use. So we may very well see something like that on an NVIDIA GPU in the future, or some other product.
Okay, so here's a question for you. Intel makes discrete GPUs. Will they sell the GPUs themselves, or will they call upon board partners to sell them for them?
Intel has enough experience selling things directly that they could do it on their own. The catch is how serious they are about the consumer side of matters. So the advantage of using board partners is that board partners get you a larger chunk of the shelf space, instead of one product, you have 10 products that are all based on the same GPU, so they take up 10 times as much space, and you get better sales that way. The other issue is that it allows a little differentiation, so you know this guy specializes in support, this guy specializes in LED RGB lighting, this guy specializes in big fans, etc. So it allows a bit more variation, but again, it's all about how serious you want to take consumers. If you want to completely undermine really what's now the NVIDIA empire, then yes, you work with board partners, but board partners have their own margins they want to hit. If you just want to do a high margin business and you want to essentially outcompete based on the strength of your brand and your technology, then you sell it yourself. And NVIDIA already tinkers with this. They sell their Founders Edition cards through their own website. So it would not be too terribly unusual for Intel to just go all internal.
I mean, the DGX one, it's made by it's made by a Chinese OEM, but it's sold under the NVIDIA brand. So
correct, yeah. That's sort of a whole other event there because it's a full-on system as opposed to an add-in card. But yeah, Intel's fully capable of doing everything they need internally, and certainly that's the best option to go for the kind of margins they want to hit.
And there's not much more to say on what potentially Intel could do in a few years with Raj Koduri. I do want to touch on one point because I know it's been brought up several times. Is that how can Raja go between two very distinct competing companies in such a short time? Shouldn't there be a non-compete clause?
There may very well have been a non-compete clause, but those aren't valid in California. So that's where Roger is based out of. That's where one of Intel's big offices is. So whether there was or not, they can get around it. Now, there certainly are potential issues for IP infringement, and AMD has already said to the press that if necessary, they'll vigorously defend their IP. But I don't really see this as being something where AMD's IP is threatened. In fact, the biggest threat to AMD is going to be the fact that there's a risk here that they're going to become the third wheel in what is normally a two-man race.
With revenues either flat or declining.
Exactly. I mean, AMD has played second fiddle to NVIDIA now for several years in the GPU space, but their job becomes all the harder if Intel offers discrete GPUs as well, because unlike AMD, Intel is very well capitalized and they can afford to spend NVIDIA-like budgets on GPU R&D.
Well, I mean, one of the reasons behind this push to discrete graphics is probably when Intel hired Murthy Rundachala from Qualcomm 2 years ago now, and he's gutted most of the mobile business, the Atom business. He's gutted IoT, if I remember correctly. I mean, he's literally taken most of the projects that Intel has on its books that doesn't make any money or has been losing money for the last 2 or 3 years and cut them. So I've got a feeling that he's essentially said, okay, let's do this. The total addressable market is sufficiently high. It's a market we should be playing in, but you have X amount of years to execute.
Sure, and that would make a whole lot of sense. Now, this has to be a long-term plan. Again, this is 4 years to develop a GPU here, even for somebody like Intel. So, this is a minimum of, they start now, they find out in 2023 whether it really works or not. So, if this doesn't work, then, we might be talking about Raja leaving Intel here, but not for another half-decade.
How can Intel compete with something like CUDA?
That is a very good question, and truthfully, I don't have a great answer for that one at the moment. Again, Intel has much more in the way of resources than AMD did. AMD never had the developer resources necessary to develop their own full ecosystem. Instead, they're really only hitting the ground running now with the ROCm platform, Radeon Open Compute platform. And even that still sort of leverages the open source community. Intel can certainly hire developers to put together the tools, and Intel has plenty of their own software developers who are responsible for things like their the various compilers and whatnot, but they don't have the same expertise that NVIDIA has developed in terms of platforms. Even Xeon Phi, with its GPU-like design, doesn't quite capture the same sort of platformness as CUDA.
Well, I mean, the enterprise market that are using CUDA stick with CUDA because CUDA is a multi-year development project that's been tried and tested, and it works. I mean, OpenCL has tried to muscle into the market and not really got as far as perhaps OpenCL developers would have wanted. Now, Intel's first goal would be, great, support OpenCL. That's going to be pretty standard as it goes on. I mean, when Intel developed Larrabee and Xeon Phi, now I will state that there were potentially graphics versions of Larrabee floating around, not necessarily at retail, but they existed and apparently it worked okay.
Okay-ish, not really, yeah.
But the idea behind Larrabee was to have essentially an x86 enabled graphics card. Now, should Intel perhaps go down the let's have a graphics card that supports x86?
I mean, they can certainly try to do that. I really don't think x86 is going to be something that's going to do Intel. Yeah, maybe a subset.
Or a subset.
x86 in a graphics card. I mean, even Xeon Phi. If you take a look at Xeon Phi, where it succeeds and where it fails doesn't really seem to be impacted by its x86ness. Yes, it can boot as its own processor. It doesn't need a host CPU, but the core is very small, so it's not as if you can do big single-threaded heavy workloads on Xeon Phi. So at least everything I've seen where Xeon Phi does do well, it's not really because of the x86ness. So a GPU like that would surprise me. At the same time, however, it is easy to underestimate Intel. So
I think Xeon Phi kind of fails those because you've got AVX 512 units and each one has a separate core in control, whereas in a GPU you have upwards of potentially 4,000 units under singular control almost.
I'm not sure if I'd go that far, to be perfectly honest. If we want to start comparing architectures, to take a page out of NVIDIA's architecture, the SMXs are pretty independent.
But doesn't the thread scheduler just dispatch threads to each SMX?
Well, dispatches work. I wouldn't necessarily call it threads, and this is really getting into nitty-gritty where I'd need to pull up an architecture diagram and spend a couple of hours doing research before I could say something super intelligent, but it's not 2,000, 3,000, 4,000 CUDA cores behind a single scheduler here.
I mean, Intel could create a new paradigm. They could try and leverage existing paradigms. We don't really know. I'm sure Raja has ideas. I mean, he's just spent 40 days on leave. I'm sure he's been thinking of something.
Oh, I'm sure he's been thinking of a lot of things. So it's very interesting to see because if we assume the scenario where they're just going to start with a new design now, and that's going to be the make-or-break design, then we're talking about something 4 years off. Trying to extrapolate from current GPUs would be difficult. If taking, for example, NVIDIA's current situation, Volta launched this year 2017. If we tried to extrapolate Volta from 2013, that was Kepler. And Kepler was a good GPU, don't get me wrong, but Volta has made so many changes to the architecture, specifically for machine learning and these other neural network type tests, that you would not have, as an outsider, we would not have been able to predict that in 2013. Similarly, the GPUs of 2022, while they're clearly going to be descended from today's GPUs, I don't believe for a second that they're going to look exactly like Volta.
I mean, show me somebody who predicted NVIDIA's Tensor cores 4 years ago, I guess.
Exactly. I mean, NVIDIA made a big bet on machine learning. It's paid off handsomely, and that's a bet that they started on even before 2013 when they sort of played the software side earlier in the decade. But still, that's very much an internal sort of look that it's difficult to see as an outsider.
Either way, it's going to be fun, but we're still going to have to wait a few years. I'm sure when they start sampling cards, you'll go at it with a knife and fork and devour it as soon as you can. I'm hoping that they will be open. I mean, Raja going to Intel, hopefully he brings some of the openness that AMD has to Intel, and they expose a good deal about what's happening under the hood. I mean, Intel and AMD have very differing views on what they provide to the press these days. Hope, fingers crossed, Raja can bring some of that to Intel. Just expect an invite to a big press event sometime, I guess, in 2021.
Yeah, this is absolutely going to be fun. Just Intel's announcement has already put things in motion to turn the discrete GPU industry on its head. I don't know where we're going to end up, but it's going to be a very fun run. This is the most significant thing to happen in this industry in a decade, probably since NVIDIA started with CUDA and unified GPUs all the way back in 2007.
I'm going to make a very tenuous link and say the next thing we're going to talk about is from a company that if they wanted to enter the discrete GPU market, they would have enough money to do so. Though that's a topic for another discussions. Next thing to talk about is Qualcomm Centriq. So perhaps a bit of antithesis to the podcast, but Centriq is the first. Not the first. That's wrong. They are a serious assault onto ARM coming into the server market, more so than we've seen from Cavium with ThunderX or with Applied Micro with XGene. This is a major player whose entire mobile SoC workspace revolves around ARM and ARM-derived designs, pushing a 48-core ARM v8 chip into enterprise, into servers, specifically for what they're calling cloud services. So this is containers, this is Azure containers or AWS Docker units, just services that operate at scale. They're not necessarily going for high performance, but services that operate at scale. I mean, Qualcomm has a lot of money, they have a lot of designers, a lot of very good designers, and they've decided to put some of them onto this server chip that they say is their fifth generation custom design. They did a nice big microarchitecture exposure at Hot Chips in August, which I wrote up and is on the website, and today is essentially the official announcement. So we get more details, like this is the biggest chip that's currently made on Samsung's 10 nanometer LPE FinFET process. It's coming in at 18 billion transistors. Does that number just blow your mind? 18 billion?
Yes, it does. I remember when I used to have CPUs and video cards where the number of transistors would be into the millions, small millions, 4 million, 6 million, 10 million. So to be billions just for server chip, yes, it's very mind blowing. And so for that matter is the die size, just shy of 400 square millimeters. That's, especially for as young as Samsung's 10 nanometer process is, that's huge. That's a medium to large size GPU right there.
No doubt we'll see more orders of magnitude over the next decade. But 18 billion is still a lot. Especially for a 10 nanometer process. I was going through the current products we see on the various 10 nanometer, that's 10 nanometer in inverted commas, however you want to call the processors. We have Apple's A11 Bionic and the Kirin 970. They're sort of in the 100 square millimeter range. They're both chips for smartphones. We've seen
they are. Those are big for smartphones. I should throw in there. Most vendors don't even want to have a chip that big in there because of the costs. And
to come out with, even those chips, they have to fight things like yield and defect rate. To make sure that they're getting the premium. When you have new processors, you typically start with small chips because if the defect rate is 5 per square centimeter or half per square centimeter, the smaller the chips are, the fewer you're throwing away. So this is a large chip on a very recent, very modern process, and like I say, 48 cores. These are ARM v8 based. Qualcomm are quoting that in the tasks that they want it to perform for, it's running at roughly the equivalent per thread of some of Intel Xeons that they want to compare it against. The whole chip has 60 megabytes of L3 cache. Think of that what you will. I mean, for cloud services, that's important, especially if you want to separate it, into containers having their own L3 cache, or if you want to power certain parts down to keep it light. I mean, it's much lower TDP than the Intel Xeon chips. I mean, the top Intel Xeon chip currently is 205 watts. That's the Xeon Platinum 8180 with 28 cores, 205 watts. Now, Qualcomm is comparing this to their high-end version of the Centriq 2400, and the Centriq only has a TDP of 120 watts, and they're stating that on most workloads it barely breaks 80 watts anyway. Now, whether that's a question if the cores can be fed or whether the algorithms are parallelizable or the workload is parallelizable or whatever, we'll have to wait until Johan gets his hands on some. But again, that Intel Xeon chip that retails at the MSRP is 10,000. Qualcomm is selling theirs for 2,000. The three main goals for Qualcomm here are performance per watt, overall performance, and price. And I want to say, based on what the results that they've given, they've achieved all three. But I would also argue that a lot of the people in the enterprise ARM space also say they beat Intel on all the three segments anyway. But they've not made a dent necessarily. I mean, they made a dent in niches, but not necessarily in the wider server market.
Yeah, unfortunately, there are a lot of dead bodies on the path to ARM server dominance. AMD, C-Micro efforts, Caldexia, etc., have all failed trying to do ARM servers, which doesn't mean the idea is not doable, just that it's going to be very challenging. And I find this especially interesting coming from Qualcomm, not because this isn't a natural avenue of growth, but because keep in mind that Qualcomm, for as strong of a company as they are, their first and foremost business is still licensing, not chip building. So to have not quite a chip builder Qualcomm come in and build quite a big of a chip here in the Centriq is really a big change for the company.
I love the fact that, so they launched 3 SKUs with 48, 46, and 40 cores. So the minimum spec you can get is 40. I love the fact that the price for the 40 core is $888. I mean, I know 8 is China's favorite number, so stick 3 on the price and you might sell well in China. I don't know. But no, so they provided some benchmark scores with interpolated Intel results. I would love to see a direct shootout, which is what Johan's going to do when he finally gets his hands on the chip. They've stated extensive Linux support, especially for the workloads that it wants to target. With it being ARM v8 compliant, it means that anything that's already ARM v8 written for ARM v8 or compiled in ARM v8 will work. It's just a case of optimizing for specific microarchitectures. One thing was interesting is that several months ago they stated that the chip would support Windows Server using the Windows on Snapdragon initiative that is going to be coming to laptops fairly soon. They say that's going to translate into the server space, but in this announcement they didn't mention that. So I wonder what's going on with that. We need to speak to Qualcomm to find out.
I would be surprised if anything's happened to it per se. It's just that given the market Qualcomm wants to go after, Linux is far more important than Windows.
Agreed. Yeah, there's that. I mean, they're saying that the chips are currently shipping for revenue now. So they're quite happy to take people's money, especially if you happen to be a cloud provider. I mean, for the announcement this week, they pulled out Alibaba, Google, Hewlett-Packard Enterprise, and Microsoft, all of whom have container-based distribution networks. I didn't see an Amazon necessarily in the announcement, but that's who they're going after. If I'm under the impression that if you want to get involved into the Centriq system, you have to speak to your local Qualcomm reps. whether this goes beyond serious cloud providers, we'll see. They have already announced the name of their next generation of this product. So it's going to be called Qualcomm Firetail, using Saphira cores. Now both Firetail and Saphira are already trademarked, so it's clear they're going to do them. But hey, it's another player in the ARM server space. Ecosystem is going to be everything. It always is.
It is. It's interesting you mentioned cloud service providers, because as crazy as it might sound, Qualcomm doesn't need to sell to anybody besides the cloud service providers. The major cloud service providers are so big that they can sustain ecosystems on your own. Just being able to sell to Microsoft, Facebook, and Amazon within the U.S. gives you a significant customer base right there. You throw in overseas like Alibaba, and you have a whole business right there. There are companies already doing smaller scale projects who might only sell to Facebook. Google has their whole TPUs, which they don't even sell, which they only use for their cloud computing efforts. So, yeah, Qualcomm doesn't necessarily have to attract smaller players. They don't have to attract small, medium, or even large businesses. If they can nail the cloud service providers, that alone could give them a solid business.
I love what I love about the fact of what Qualcomm's done around this product is something that they don't do necessarily around the mobile products. In the fact that they've been open. We got essentially almost a full microarchitecture deep dive several months ago. I mean, you poke some divisions of Qualcomm and they won't tell you because they want to keep it a secret. But Qualcomm's been very open with this, and for that I'm glad.
It is, and that's sort of the difference between consumer and server products. They're going into a far less competitive market, I guess the best way to say it. There aren't a bunch of upstarts that can potentially upset them. They're working for very conservative buyers, etc. Whereas in the consumer space, there are many more companies developing SoCs. There are very much IP issues on the GPU side, etc. So Qualcomm doesn't have the same need for secrecy on their server products as they do their consumer products.
At the presentation, we've got Anand Chandareska holding a wafer of these things. If anybody at Qualcomm has a spare wafer lying around, let me know. I'll send you my address. Looks kind of cool. That's my plug.
You have one of those? I'll take a Power 9 wafer if anybody's offering. Apparently there's they're making Power 9 on 200mm wafers, not the big 300mm wafers, just 200mm wafers at about 60 chips per wafer there, and one of those would look great in my office.
I know the tweet that you're referring to, and I think I guessed wrong when I said 200mm. It looked kind of small, but I think it's actually on a 300. But either way, yeah. Another thing that we haven't necessarily got to this week, because Supercomputing 2017 is that show is next week, where a lot of this stuff will be demoed. Power 9 finally taping out and getting perhaps some performance numbers soon is going to be another interesting topic for Johan to delve into.
Power 9 is an extremely specialized piece of silicon, but it's the first CPU out that's going to support NVLink, and that could have some very interesting repercussions for the HPC market.
Oh, that's right. We already see NVLink between GPUs in NVIDIA's TGX, but not to the CPUs yet.
Exactly. So this is sort of the next stage in NVIDIA's HPC evolution. Also, it's going to be a fundamental building block in the new supercomputers here they're going to be due for the United States Department of Energy over the next few years. It's
all towards the march for exascale, to quote somebody's marketing materials.
It is. I mean, just going off a wild tangent here now, the U.S. government is increasingly concerned about China beating them to doing exascale. I won't get into the political ramifications here, but it means both sides are going to spin big to try to be first.
As long as it filters down to the common folk like us, I'm okay with that.
Well, it is certainly paying NVIDIA's bills right now, that's for sure.
All they need is some high-end competition.
And it looks like Intel's going to give it to them.
And so we come almost full circle. Thanks, Ryan, for joining me on the podcast.
Not a problem. Always great to be here.
Good to have you. Good to have you. Always good to have your insights, especially when we start talking graphics. And it's going to be weird seeing Raja Koduri in a blue T-shirt from now on. But we'll see.
It's a weird kind of week.
Again, thanks Ryan, and thanks everybody for listening. You've been listening to the AnandTech podcast.